So hi again, back to the fallacies, this time specific fallacies, namely the violations of the validity rule, which is number 7 of the rules for critical discussion. According to the validity rule, reasoning in the argumentation that is presented as logically valid may not contain logical errors. Now actually, in everyday discussions, all the argumentation is presented as though it's logically valid. So we can assume that this requirement is fulfilled and then take a look at whether there's actually no logical mistakes. So logical mistake is a mistake in the validity of the reasoning. And for that, you then need to know what is validity. And validity is defined as a standpoint, or as logicians would like to say, conclusion. It cannot be untrue if the arguments, or if you're a logician, you want to say premises, are true. Or if you consider these premises to be true, hypothetically speaking. So it's all about the form of the reasoning. That should be waterproof, it should be really tight, it should be logical. Now it goes wrong in examples like this one. Here we have a standpoint, it's the first part, namely prices for flights will be low right now. And then we have an argument, or you could call it a premise, as I said. So there's premise 1, there isn't any demand, and premise 2, the higher the demand, the higher the prices. Now think about this argument for a second, because it is a little bit odd. Because you can imagine, for instance, a situation in which kerosene is really very expensive, and so regardless of the demand of flights, it is making flights still very costly. So the price is maybe not lowered by this lower demand. Or it could be that there are also fewer flights, and so the price for the flights are really still the same, or maybe even higher. In other words, this argumentation is invalid because the standpoint can be untrue while the arguments are true. And I can also show you this by means of the standard reasoning patterns that we have already discussed and that are always logically valid. And those are the modus ponens and the modus tollens. If you follow these reasoning patterns, then you can be said to have a valid argument. So we can use them actually to reconstruct our example and see if this example really follows the modus ponens or the modus tollens. Now, to decide which one we need, we should take a look at the exact formulation of the example. We have prices will be low right now because there is not any demand. And then we have a sort of if P, if there's a higher demand than Q, there are higher prices formulation. So we can actually read for will be low right now that it's not high. So for these reasons, it is useful to use the modus tollens. So we can discard the modus ponens now. Let's discard it. Those are the special effects that I make. Anyway, now we have the modus tollens here, and we can fill out the P's and the Q's. So I already said P is a higher demand, so a rise in demand, and Q is then a rise in prices. So that leads to the following formulation. Now don't look at the example, check what we should fill out according to the modus tollens. So we should fill out not a rise in prices, so not Q. And then if we have that, we can conclude that there is not a rising in demand, so not P. Now take a look at the example again and check what the exact standpoint is. Here we have it, so prices for flights will be low right now. But in fact, as you can see, that is not the same as the conclusion that we should have drawn, namely that there's no rise in demand. In fact, we have swapped our P's and Q's here, and that is a well-known fallacy. So we don't follow the modus tollens, we do not have a valid reasoning scheme. This is called denying the antecedent. And the antecedent here is always the thing that comes after the comma here. So you have the, I say it incorrectly, the thing that comes before the comma here. So we have, this is the antecedent, sorry about that. I'll call it A antecedent. And now you can see my drawing skills help, because here we have the consequence, the conclusion from the antecedent. Anyway, we're denying it, so we have not A. This is the logical symbol for not A. Oops, it's just one stripe here. It should be one stripe, so not A. And we conclude from that's not Q, but you cannot do that. Okay, I hope this isn't confusing. Let's move on quickly. You can also make another mistake here with the modus ponens, and I can show you that with adapting our example a little bit. So take a look at this formulation of our example. So I could have a standpoint that there must have been an increased demand for flights, because I argue the prices rose, and the higher the demand, higher the prices. So here we don't have any negation, so we discard the modus tollens. I'll not make any sounds here. And we can fill out our P's and Q's again. So the higher the demand, the higher the prices was the same as last time. So we have, if demand rises, then prices rise. Now, don't look at the example again. Just check out what should be P, and that is a rise in demand, basically. So that's the other argument. So if there's a rise in demand, and if demand rises, then prices rise, then you should logically conclude that prices rise, right? So this is what is a valid argument. Now take a look again at the example. And here what you see is that the standpoints, there must have been a demand or an increased demand for flights. That is something that is actually should have been P here, but we list it here in the conclusion. So what we did again is swap the P and the Q. And you can see that this reasoning doesn't hold either, because it could be the case that prices rose because of what I just said. So material costs, they rise, or there are fewer, there's fewer personnel, and so there's fewer flights, and so the prices rise. So the higher demand isn't the only explanation, I should say, for a higher price, right? So you can see that doesn't really follow. This one is called the fallacy of affirming the consequence. And so I just explained rather chaotically that this here is a consequence, and you're affirming that. And you shouldn't do that, because you should actually affirm here. You should affirm the antecedent. Anyway, now you've seen two ways in which Rule 7 can be violated. So by denying the antecedent or affirming the consequence. But there are two more ways in which you can violate this rule. And that is by means of the fallacy of division or the fallacy of composition. Now I'll give you an example of such a fallacy, and I can already tell you that it is a fallacy. There's something weird about this, because the whole and the parts in the argument are confused. But the question here is this a fallacy of division or composition? So we have the soccer team is great because each player is great, which doesn't really hold. I mean, I'm sure you can think of a soccer team that is not at all great, while there are star players in that team. So here you can see, no, it doesn't really hold. So what is it, division or composition? I can tell you now, it's a fallacy of composition. And the reason for that is that the whole is mentioned in the standpoint, so that's this upper part. And the parts are in the argument. And if you reason from these parts towards the whole, it's called composition. If we had the argument, each soccer player is great because the team is great, then you argue from the whole to the parts, and that is called division. Last question before we stop. This one. Can you think of any example of reasoning by division or composition that is perfectly fine? So can you think of an example of reasoning by division, composition that's perfectly fine? In other words, that's not fallacious, in which there are no logical errors. So if you want more time, stop the recording. I'll give you an answer now, because there are these kind of reasonings that are non-fallacious, and this is an example of one. So the chair is made of wood because each of its parts is made of wood. And here you have to assume that even the little screws and the little thingies in the chair, they're all made of wood. But if that is the case, then there's nothing wrong with the standpoint here. It's really perfectly fine. So there are no logical errors. So my question now is, why is this? What makes this reasonable while our other examples were fallacious? Okay, you can take a break again, but here is my explanation. And there is an explanation that more or less holds, and that is that in this case, we have similar evaluation criteria for the parts and for the whole. And that is because being made of wood is a subjective evaluation. I mean, it doesn't differ for part or whole. But for the team, for instance, and the soccer players, that is, you have different evaluation criteria. So you evaluate the quality of a soccer player differently from the quality of a team, right? So you have the saying, the whole is bigger than its part, or I should have checked it, but anyway, it comes down to that there's a difference between, with the sum of the parts, so that the whole is bigger than the sum of the parts. And that is exactly the case in a team, they sometimes say, oh, they got wings and they scored so much. And it could be that they are all average soccer players, but still their team is great. Now, that's different from objective terms. Now, is it then always the case that if you have subjective evaluations, that it is a fallacy of division or a composition? Yes. Now, is it always the case that if you have objective evaluation criteria that you never have to deal with a fallacy of division or composition? The answer is no. You still have to check it for yourself, and I can illustrate it maybe this way. So here we have a question for you, and that is this reasoning fallacious? We have a standpoint. The figure is triangular because an argument, each of its parts are triangular. And triangularity is usually considered to be an objective criterion, right? So I can draw a little triangle here. So then, now comes the answer. So hope you're ready. But see here, I have another triangle, and these are two triangles. So it seems to hold, but now we have this envelope shape, or maybe this is sort of a square or a rectangular figure, I don't know. We can continue our drawing. I mean, this is a little house. So no, this reasoning is not reasonable. It is fallacious. It's a fallacy of composition, even though there are objective evaluation criteria involved. So what does this tell us? That with subjective criteria, yes, you can always immediately speak of a fallacy of division or of composition, depending on what is in the standpoint and what is in the argument. Otherwise, you still have to think about it. Okay, that's it for now. Thanks for listening again, and check out the other recording.